Hello everybody. Now I'm going to teach you how to solve polynomials in a case where you have imaginary roots. Alright, looking at this example. As I did in my previous videos, I went ahead and skipped the first few steps simply because you have had enough practice and you know how to do it. So I'm going to go ahead and start with that very next step of graphing this function. So as you can see, when I graph this function, usually we see the x-axis crossed a couple of times. Maybe 3 times, 4 times, whatever the highest degree is. But here we see it only crosses 1 time. And -2. So that's the only root I'm going to use. The reason why is because from looking at this graph, we can already tell our other roots are imaginary numbers. So let's go ahead and do synthetic division for -2. Write my coefficients out. 3, 7, 7, and 10. Bring down my first number. Multiply, add straight down, multiply, add straight down, multiply, add straight down. Now, in this case, we do not have to do synthetic division again. You want to know why? We already have our A, B, and C. So, of course, it's going to be 3x squared plus 1x plus 5. So now we can move on to the step of doing the quadratic formula. So it'll be -1 plus or minus square root of 1 squared minus 4 times A, which is 3, times C, which is 5, all over 2 times my A. All right, don't forget, you always type in the numbers under the square root into your calculator. So that'll be 1 squared minus 4 times 3 times 5. And then I'll get -1 plus or minus the square root of -59. All over 6. Now, under that square root, you see a negative sign, don't you? You know what that means? You have to pull out an I. So technically, this is -1 plus or minus -I times the square root of 59 over 6. Now, usually we'll take that square root and try to see if we can break it down or simplify it. Well, the only thing that multiplies to give me 59 is 1 and 59. So therefore, I can't simplify it. So I'll leave it the way it is. So my 2 separate roots are -1 plus I square root of 59 over 6. And the second one is -1 minus I square root of 59 over 6. And don't forget the first root that you found from the graph, which was -2. All right, the complete factorization, it'll be x plus 2, and then, wait a minute. We can't even write the complete factorization from the square roots. We have a -1 plus I. We have an imaginary number radical. So in cases like this, you go back to your synthetic division step, and you pull that quadratic polynomial and write that as your complete factorization. So it'll be 3x squared plus x plus 5. And that's it.